Good morning. I'm Margie O'Driscoll, and on behalf of the Center for Innovation's Board of Directors, I'd like to welcome you to today's webinar. The mission of the center is to catalyze innovation in the architecture, engineering, and construction industry for a better tomorrow for all people. So we thank you for joining us today. We'd like to take a moment to express our gratitude to the many sponsors who make our work possible. We wouldn't be here today without your support. Thank you. We would also be remiss to not share our deep pain and sadness over the loss of so many lives in the Middle East. I'd like to share an email I received from the chancellor at UC Berkeley yesterday. The email quoted Palestinian professor Dr. Hatim Bazian and Israeli professor Dr. Ron Hassner, who together wrote this message to the university community. We are two professors on this campus who disagree vehemently, but we have always treated one another with respect and dignity. We love this campus and its diverse communities and all of our students, and are heartbroken to hear of incidents of near violence between students in the recent days. We will not tolerate our students harming one another. Disagreement and differing points of view are an essential part of campus life, and we expect that you will treat one another with the same respect and dignity that we are modeling here. This is a sobering message for all of us as we grapple with the unimaginable horror we have seen in our news feeds over the past few days. This morning, the Center for Innovation is pleased to host a conversation with Anthony Hauck. Anthony and I have had such a great time getting to know each other as we prepared for today's webinar. Before I introduce Anthony, a word about our webinar protocols. We're recording this session and we'll place it on our website, centerforinnovation.org, in the coming days. Our webinars are now available as podcasts, so check them out wherever you download your podcasts. We look forward to your comments and questions, so please use the chat box or Q&A to share them. Here's a little bit about Anthony. He's the Chief Product Officer and co-founder of Hypar. After 2 decades in architecture, engineering, construction, and IT, Anthony decided to begin a new career in innovative software development. He was the Director of Product Management at Revit and the Director of Product Strategy for AEC Generative Design at Autodesk before founding Hypar with his partner, Ian Keough, in 2018. Although there are many, and I do mean many things Anthony and I could talk about today, we've asked Anthony to discuss the Hypar platform that helps the AEC community create and share building systems built on open standards. Anthony's going to share a bit about his personal innovation story and how the Hypar platform was created. We've also asked him to talk a little bit about his forecast for what lies ahead for the integration of open standards and what we like to call design for the other 99%. I'm sure we're going to find some other interesting topics to explore together. So Anthony, please take it away.
Thank you, Margie. Hi, folks. Nice to have all of you here at the webinar today. Thank you for attending. Margie and I were talking right before we came on, and she was sort of interested in, is there some backstory here to what you do? And I guess I'd have to reach back to when I was working as an architect in Los Angeles and back in the 90s and early 90s, and just first started doing my own computer programming. And one of the things I just found fascinating was that a computer could start suggesting things to you that you did not think of at the time, and how you could interact with some kind of computer program to give you more ideas. And now it's the kind of thing we're getting used to now, because people are using things like ChatGPT to generate ideas and riff off of. And this is just the idea that a machine could help you create new things has always been fascinating for me for the last he said 30 years. So in any case, a little bit about what we're doing at Hypar. So for folks that are curious on, why, what does this name about Hypar mean? So this is actually Hypar is I'm gonna go back here, is a hyperbolic parabola, assuming I can go back. There we go. A hyper is a hyperbolic parabola. It's a shorthand. And what you see actually down below in one of our, cover slides is one of those things. It's a double curved surface. And you see this a lot in early computer generation ideas because it's a fairly complex shape, and it's also pretty interesting structurally. And what we actually do is we are a collaborative cloud platform for generative design, construction, and building product configuration. Now, we found my partner and I are both architects, and so originally, when we started Hypar, we were kind of exclusively oriented toward talking with architects, and then it turned out that folks in construction and building products started talking to us a lot because they were very interested in automating procedures that were not in the field and not in the factory, but in the office as well. So that kind of thinking about being efficient in producing physical objects, they also started thinking about, can you also be efficient through automation and artificial intelligence in generating the ideas that result in those physical objects? So what's ended up happening is we end up with customers kind of across the design, build, and construction spectrum. These are a few of the customers that we work with. People like BBC, who create volumetric modules out of California and Philadelphia, Aptitude, and we'll see a little of their work about some low voltage engineering that they do, Arco Murray, which produces warehouses, etc. And so what we found in common with all of these customers is they saw an opportunity to use computation to enhance their existing processes, either in speed most often, and sometimes even in quality when they're trying to normalize their approaches toward building. This is a very early video from the first couple of years of Hypar, but it illustrates a lot about what we're trying to do. We're pretty serious about being a platform. So what you're seeing here is there's a collection of little programs on the left, and some of them actually come out of the box if you access Hypar, and some of them were added by a gentleman named Marco Giuliani. Those are the MJ things that you're seeing on the left. And what he did was kind of mix and match a bunch of parts and pieces sitting on Hypar, and then added a couple so that he could create a program to define dwelling units and then pack them into various generated building envelopes. And then surface a bunch of statistics around that. And so using Hypar as a very rapid option generator that starts to give some indication, of the performance of the proposed design. We are entirely on the web. We can kind of scale infinitely because we're using virtual machines everywhere, and people customize our platform into various needs. So one of the things, since we are an open platform, is we also work with partners. There's a company called Foresight Digital, and they work on medical programming. And so they approached us and said, hey, could you take one of our programs and bring that into Hypar, and could you pack that into an existing building? And so, at first, we just bring in from their download a large hospital program, and at the first step, we just kind of lay this all out on a landscape to give you kind of a comparison of space use between the different departments. The fun part happens in here, where we go and say, now push it all into the building for me button. And so we're filling that part T that's been defined in the existing building and trying to put all the spaces at their full square footage. And of course, as never happens in the real world, the program is bigger than the building. And so the engineer here is trying to fix this by adding 2 more stories onto the tower. And We got a lot closer, but not all the way. And maybe that's the time to pick up the phone and talk to the client about, does everybody really need all this space? Because we're at the limit. Connected with these kind of design analyses, we, offer different kinds of visualizations like this, which are all, live and editable, because we think people should be able to, kind of interact with their designs in a bunch of different ways. What a lot of these kind of earlier technology explorations led to are things like this. We work with a customer in Europe. One of their businesses is putting up multifamily residential as modular construction in the sense of flat pack, and also bathroom modules. And so they asked, like, can you show us, how you could, quickly lay out a residential and building? And here, I'm changing just the kind of very gross, like, I want an H building, I want a U building, but then we're generating all the units that go in there, and then you'll see kind of the unassigned spaces where the algorithm was like, I don't really know how to fit this in here, so human, please intervene. And what you're seeing here is, a human actually intervening. So what we do is we kind of combine these automatic processes along with human intervention. And so what the designer here is doing is kind of going around the facade and saying, no, I don't want, the glass there. I actually want a brick facade there, and selecting off a catalog to apply the different materials and getting another look at it. So there's the possibility, with this kind of automation, that you can see a lot of different approaches really, really rapidly before you've invested, and down to like how you lay out your individual units. And so this kind of approach just keeps kind of getting tighter and tighter and more detailed. So this is, we do this every now and then, like, how fast can you make a floor plan using Hypar? And so we keep there's a clock running down. I have a previous version of this video where we were at 9 minutes to come up with a new floor plan. This is working off an import from Revit. So we brought in the core and the shell from Revit, and now we're using Hypar to lay out the spaces. And you'll see here that, a lot of this was manual, just like laying out the spaces, but individually in each of these space types, we're actually furnishing it in a generative way. And so each of the meeting rooms, for example, as it changes size, changes configuration. So here's another more detailed one where we're kind of like bringing in an external building program. And, similar to what you saw a couple of videos back, we bring in a program. And then in this case, this is fairly new functionality for us, that you can do this kind of, draggy droppy thing, and then start configuring up your suites, etc. And so what we found in talking to folks in space planning and especially in healthcare space planning, is that, they kind of want to play with this stuff as Lego bricks and put it together. And we refer to this as kind of a inside out construction, where you kind of know how the characteristics of the spaces, and now you need to combine them in certain ways. And they wanted that freedom to interact with this kind of planning directly. Something that we'll probably talk about, a little more in the discussion between Margie and I, and any questions that come in, is all the things that you see so far work because we base this all on an open standard that we created. Back about 5 years ago, we did a pretty deep investigation into IFC, found it for various technical reasons somewhat unsuitable for using on lightweight web services. And so we invented a library called Elements that represents different kinds of building components, including room types like you're seeing here. But then we also open sourced it, made it extensible, and kept it from being tied to our services so that people can use it in other contexts. And we have, several colleague companies around the world who actually kind of adopted Elements as their internal data representation for their building components. We'll talk more about that. And but since this is kind of an open data standard, then you can do things fairly easily, like add a whole new system into this. And we'll talk about some of these systems coming up, where like here, we're just going to add a ceiling into a floor plan similar to some of the things you've seen. Now, we've supplied this this ceiling configurator, but because this is an open platform, anybody can bring a ceiling configurator and put it in. As long as they're using elements, it will talk to everything inside Hypar. So here we're both configuring ceilings, and we're getting takeoffs on our tile counts and our lineal grid. And so you can see where this is where folks in construction, design, build really started getting interested, because since this stuff is all being generated, it can also be quantified. Since you start with this kind of thing, you're laying in just a ceiling system. One of the reasons we did that is we were also looking at sprinkler systems, and we wanted the sprinkler heads to have some place to be. So we made ceilings, but then we started working on things like this. And this gets more into kind of subsystems of the building, where the first thing we're going to do is automatically try to put a sprinkler head into every one of these rooms and route it all the way back with pipe sizing back to the identified water source. So here, we've laid out all the sprinklers, they're real pipes, more about this later. And then the fun part in this one happens when you sort of give the algorithm a challenge, and you say, well, this is all fine and well, but you know what, I've got this giant piece of equipment right here, and I'm not really going to be able to route my sprinklers properly through there. And so now go you and find a route again. Obviously, you could eventually stymie this thing by putting enough obstacles in the way. But here, what it's doing is it's hunting down the corridors to see if it can find a route to get the sprinkler head back into every room with that obstacle. And here it's successful. So these are the kind of things that we find are very tedious tasks for people, and we believe is a kind of a misapplication of human capital, where there are so many problems in the world and in buildings to solve. We'd rather the computers start solving the stuff that's pretty reducible to a set of rules or an AI algorithm or other approaches. We get very detailed sometimes. For one customer, they just wanted some kind of configurator that worked off their cabinet catalog, where people could just move their appliances around, and then reconfigure lineal kitchens. And sometimes, it's simple things like this. It's not, this isn't going to solve world hunger, but something that just lets people make decisions very, very quickly about something they care about. And here we're just using, their catalog to readjust all these cabinets. And from the, this sort of surface finish space planning thing all the way up to, all kinds of other systems. So this is something that's on, publicly on the platform right now, where, you can kind of give it a couple of hints on a site, and it will generate from a bunch of parameters a timber structure and quantify all that for you. We've actually done this also in a commercial sense for one manufacturer, and particularize this down to, their catalog on how they deliver buildings. And so, these kind of tools let people, we think, make better predictions on what they want to do. The customer that we worked with around timber manufacturing, one of their differentiators is embodied carbon. And so they have their own equation that we deliver the results of when people design using their tool. I'm going to go a little bit live on this one. I just wanted to show you that still on kind of the detail that some people take Hypar to. This customer called Aliaxis out of Europe, and just bringing that actual thing live. Here's the system we were just looking at. Every one of these things is a part or a piece from their catalog, but these systems are fully automatically designed. So we're getting all our pipe diameters here and the system pressure. And for this particular customer, their business problem was there's an awful lot of work in roof drainage that they could get on big flat buildings that were going up everywhere between data centers and logistics. And their bottleneck was, we only have so many engineers. We need to get more projects through them. And so essentially we just spent months with their engineers finding out how they do things, which led to some inventing of some new equations to describe the behavior of water by their engineers. And now from a day and a half, they were designing these systems in about an hour and a half. Which was kind of interesting because apparently, because they deliver these systems in pieces and stages to the site, sometimes they redesign the system several times when the pipes don't get installed exactly where they need to be. So, but interesting stuff working with them. We also work with other types of engineers. This is a company called Aptitude. They do cable routing and purchasing for data centers. And so the remit here was, can we bring a configuration in from one of our customers, and can you route all the cable, through an existing data center as represented in a model? And so here, I'm doing something where I'm forcing every single cable to go through one point, which is naturally a really bad idea, and turns a bunch of cables red, and then other configurations improve it. This is the kind of process that somebody would ordinarily, do measurements inside a model at best, and then write things down and then order the cables, which, as you can imagine, again, is a very tedious process and probably a waste of humans' attention, especially people with a PE. What we're doing here is taking a task that was probably a week long and turning it into a couple of minutes. And these are the kind of things we're always looking for and recommend to folks who develop on our platform on their own, which is what feels like a misapplication of humans, and can we turn that into automation so that people can concentrate on more interesting and valuable problems? To that end, we work with Obashi. One of their dreams was we'd like to, photograph buildings in a neighborhood where we're going to build, and show the local regulators a building that might look like it. And so this is something we have a pending patent on with Obashi and Stanford Research Institute, where you can drag and drop a photograph in, and we'll create an analogous three-dimensional facade here, which can be quantified and priced and all that. And this is really about an idea about contextual fit for a building, because Obashi's business in this case is building office towers in Tokyo on spec. They manage the building for 5 years, and then they sell the building. And so one of the things that they find, they need to get through is the sort of regulatory environment. One of the interesting things I'm bringing up here is there's a video, but it's kind of more fun to do it live. Some folks have seen this in the past. This is our kind of AI prompt. And so I'm starting out with a straight one-story parking structure. I'm going to change this to 4-story podium. Let's see, try to spell it right. Podium with retail, let's say retail on the first floor, and parking above, and let's say, I don't know, 10-story office tower. And let's make that, how do we make that L-shaped? Let's see what we get. So what's happening under here, this is very similar to interactions that you would expect from any kind of natural language processor, right? And so what we're doing is essentially interpreting this prompt into procedures that create the office tower above, this kind of area of screened parking down here, and then a retail indication on the first floor. And then we can do things like instead of an office tower, we could make it a residential tower, and then different things come into play after that. So what this is doing is actually pulling parts and pieces that I've already shown you in various other videos here, and coalescing them underneath an interface that makes it very easy for somebody to start trying out options who may not necessarily have building expertise. And this is a lot of what we're about. We want to see democratization of building knowledge. We see a phenomenon that's been happening in the software industry for a really long time, which is software companies come up with something, they turn it into a toolkit, they publish it, other people build on top of it. And so what you end up with is a whole industry that's building on each other's successes to accelerate the technical load out on the internet much more rapidly than would happen otherwise. But what we've seen in AEC is a whole lot of siloed application of technologies that end up kind of cycling inside firms and eventually getting lost. I was telling Margie that I've literally heard sentences like, we used to have something like that, but we lost it on the network. We had something like that, but that guy left. And so, what was so disappointing to Ian and I was that, we would see all these wonderful things that people would develop inside design and engineering firms. And because they're not software companies, these things would end up, dying eventually, unfortunately, for lack of attention or, whatever circumstances obtain. And so we wanted to make a place where people could kind of preserve and share building knowledge if they chose. Everything that people develop on Hypar is private to them, unless they share it in whatever way they see fit within an organization, externally to the world, whatever it is, it's up to them. But the idea behind what we're doing is that with a repository coming from all over the world of building knowledge, then that building knowledge can be combined with other people's building knowledge to get to better solutions, which is what happens in the software world all the time. No one's writing assembly code anymore, right? Everybody's using kind of different toolkits that they're combining. We use a bunch of toolkits to produce Hypar, and we should all be able to stand on each other's shoulders, especially around building expertise, which is becoming so vital and rarefied these days because, as the population grows and as the needs change, especially with climate change, and dealing with those consequences, there really isn't enough talent to go around. We hear from our customers that for certain building types, they, even though they're competitors, they actually have to share talent between one another and the firms they hire, because there literally is not enough people to accomplish what they need to accomplish in the time they have. So this is what we're doing is an analog to how projects work now, right? Which is a bunch of people from disparate backgrounds, disparate expertise. They come together for a few years, they create something, and then unfortunately, a lot of times what happens is all that collected knowledge gets redispersed, and those people may never come to work together again. And so that collective knowledge is gradually degraded and lost, except in what exists in usually inadequate documentation. So finally, what we're trying to do is help the world capture what it knows about the best way of doing buildings, so that our hope is that we can make it easier for people to make really good buildings than really bad buildings. And right now it's very easy to make a very bad building. And we would like to make that very, very difficult so that the whole built environment gets better as we, cycle through both the existing fabric that we have and all the new stuff that we need to build over, the next decades. So I'll stop there. That was a lot of talk.
Wow. That's all I can say is wow. I'd love to invite our audience to add any questions either in the chat box or in the Q&A, but I'm going to start with a question. There's a word that you use quite often, for which I think there's a certain amount of irony in today in the United States, which is the word democratization. We face in the United States right now a sort of chaos in our democratic system without a Speaker in the House of Representatives, which hopefully that will be resolved quickly. But I guess what I'm wondering is, as you work globally, are you finding greater acceptance of the ideas of Hypar within the United States or outside the United States? Because it seems like you have global clients.
We do. I don't know that there's a specific regional difference. We do see it's more kind of whether the region is supporting normalization of procedures as a cultural aspect. There's I'll cite Helena Lidlo from VBC, who has 30 years in volumetric building construction. And she has, gave a presentation earlier this year where she was talking about how the US came up with modular construction, in the early 20th century. And all the folks from the Nordics, took it back and developed it. And now the Nordics are trying to reintroduce it to the United States. So I think, there are certain economic and social and cultural things that drive people toward automation and standardization. And when those obtain, we tend to get a little more traction because people tend to want to apply what they know of, factory technologies back into other processes. So a lot of the interest we get ends up being from people who produce buildings that everybody plants, trees in front of so they don't see them, right? So, data centers, warehouses, logistics centers, like all these kind of things that are so vital to our modern life and nobody thinks about. We find that people are already thinking about building in terms of a product that they deliver. And where that thinking obtains, they're always looking for something that streamlines that delivery and improves the product at the end.
Great. We have a question here from AJ Schobel. Apologies if I haven't pronounced your name correctly. Is it possible to use Hypar as CDE with different parties combining information in Hypar, also considering the various software platforms and proprietary formats?
Yeah, so we have people doing that. I would not say to the full extent that the industry hasn't imagined a CDE, because ultimately you would probably like the entirety of the project to be existing in some very well-related environment. And that includes like all the stuff that ends up, at best on PDF these days, and at worst on, scrawled pieces of paper that maybe somebody will photograph. So in some sense, no. But our environment is fully collaborative in real time. So multiple people can be working on in the environment at the same time on the same things. So in that sense, yes, it starts to become a buildup of the project state. But for certain things like I'm alluding to about document management and stuff, this is not something you want to try on Hypar, right? There's lots of good solutions out there, but because we're an open platform, and because those platforms often have open APIs, and application programming interface, for anybody who's not up on the jargon, it's possible, and people have done it, to write something for Hypar that talks from Hypar to something else, or vice versa. So one of our partners, SkyCiv, who do structural analysis in the cloud out of Australia, they've written a little connector back to their service from Hypar, so that you can analyze steel structures back using their web services. So they don't actually have anything on Hypar but that connector. So analogously, like we use things from Mapbox, for example, to show locations. Anybody, it can connect Hypar to something else. So I think, in practical terms, there probably isn't going to be one giant repository of data that's fully interrelated anytime in the near future. But I think these kind of helpful spot connections to targeted systems are going to be more and more common. And you see this in banking quite a lot, in fact, that the most important thing in there is the middleware that pulls everything together. And so sometimes that's how we see people using Hypar, is using it to connect a bunch of systems to arrive at enough information to make some kind of decision that is important.
Great. We have a question here. Other than being web-based, what are the differences between Hypar and Revit, Dynamo, or Grasshopper?
Yeah, having run Revit for a bunch of years, the differences are many and profound. I think some of the things that we're doing is also kind of learning from experiences on the Revit team, because my partner Ian invented Dynamo back when, before he eventually got acquired into Autodesk through the Vela acquisition. And so we have a lot of talks about, how these things exist in the market. Revit has ideas about how buildings go together, for right or wrong. We've tried to make an environment that has opinions out of the box if you care to use them, but are also amenable to a complete rethinking of how to put something together. So on Hypar, for example, there are representations of walls that are, somewhat similar to Revit's, just this continuous thing with some stuff inside. But there are also representations that just start out natively panelized, and so the platform itself does not have irrevocable opinions about how buildings should be assembled. It is entirely customizable to get to a point where it's producing the building you want to do. Now, that would be much similar to Grasshopper on top of Rhino, right? Where it doesn't actually have many opinions at all. It's doing pure geometry, but then of course, it's an exercise for the reader to do, everything about turning that into a representation of a building rather than, say, a cell phone. There are these, trade-offs. Like our elements library is set up to represent, components in buildings. Someone could easily, add a bunch of things that were representing components in cell phones, or, as you've seen, piping systems, or whatever it is. What the difference for us especially is finally this collaborative aspect, where we make it kind of, we hope, falling off a log easy to share what with people that you would also like to know those things. So what we found is from inside Autodesk, you get to sit with hundreds, literally, of firms and see what they're working on. And we just found, especially with Grasshopper and Dynamo, that people would develop something that was really, no kidding, brilliant, answer for some problem in a project that you probably couldn't practically do any other way other than through automation. And then what we saw over and over again is those kind of things ended up being so project specific that the next step for the next project was to start over. And I talked with a friend a few years ago at a conference, and I casually remarked, like, well, some of these visual scripts, like, you walk away for 6 months and you look at it again and you're like, what is this thing doing? And you want to start again. And he started laughing and he said, no, that just happened to me after 2 weeks. So, there's, you can accomplish tasks with any of a variety of tools. What we're trying to do is make a platform where it's easy to reuse that sort of thing in the future. It's easy to share it with other people, and it's easy to combine what other people have done with what you've done, in the hope that the result is better than it might have been otherwise. It's we've seen workflows where people try to do that in firms with something like Dynamo, and it gets pretty fraught sometimes. You have like a Dynamo script running and producing a spreadsheet. Somebody's loading the spreadsheet into another Dynamo script, and then it goes into Grasshopper, and it's like there's a lot of human intervention in there and a lot of mental model holding in your head about how that all works. And so we're hoping that this environment makes it easier with these sort of packages that go in and out of things that create building systems, that it makes it a lot easier to combine all this stuff collaboratively, and that you don't have to do it again. Our hope is so that you've got if you've got a really good facade system that works well, for your firm, and you've got that preserved project to project, but you've got a client who really hates your facade system, you've got to do something else. You don't necessarily have to extend that because it's been working for all your projects. Maybe there's a separate thing that you use for that project, either from a manufacturer, because they've got a good configurator already, or something you have to, fabricate up yourself, but then you've got in your back pocket if you ever need it again. So I think the reusability and collaborative aspects are the kind of things we're attacking here, but also the really deep customization on it being an open platform whose representations are limited literally by your imagination. And so some of the work we're doing right now, in fact, is going to extend that flexibility even further, but that's probably a story for another time.
Great. So we have a question here from Zigru Bell, who's the treasurer of the Center for Innovation. What types of innovative processes are you not able to do currently, but believe you will see changing in the near future? This is your future. Crystal ball question.
Yeah. No, one that's really top of mind for us right now. We've been putting, as you might have guessed from the presentation, a lot of time into thinking about space planning and how people sort of assemble the building fabric, right, that all the other systems are going to serve, right? So that's sort of human experience and then supporting systems. We have for a few customers actually done the sort of auto layout of whole floors and such. Our experience has been that there is so far no generalized solution that we can discover of lay out the best spaces. Like every building is so unique in that regard that what you can do is take maybe at best a good guess. On a really good day you get to 80%, and then the humans have to intervene. Now what we're hoping is there are certain sectors like healthcare, which have a lot of investment in best practices. And what's different about your average kind of healthcare building design discussion as opposed to your average stadium design discussion is healthcare, like what we envision for what our platform can enable, is kind of like an open source thing, because everything they do has to do with public health one way or another, right? And so there's an awful lot of open sharing in the healthcare industry to improve patient outcomes, because that's what everybody's after, right? It makes economic sense, it makes human sense. I mean, there's 100,000 reasons to do this. And so in that case, what that means is there's a lot of public thinking around the best way to put together a particular kind of facility. Now, the same thing applies to data centers, for example, but of course, all the people who build data centers are very much interested in having an edge over their competition. And so there's not a whole lot of sharing going on in that sector by contrast, right? So we think that there are best practices out there. I mean, when I was first started talking about generative design and I was still with Autodesk, I really started looking heavily into this and the history thereof, which starts around 1963 or so, of using computers to generate buildings, and discovered that, name your arbitrary, large area volume, and I can fill it with, research papers telling you what's the best way to build a building of various kinds. And the question I started to ask myself is, this is great. Like, I'm reading these research papers. I'm like, these are really good ideas. Where is the software that helps me do this? And if the answer was it exists, the answer was about where it was it exists on a professor's server under his desk where his graduate students use it every year. And so what we wanted to provide a way for that kind of, encapsulated knowledge, if it's just sitting in a research paper or, actually instantiated in software, to actually get out there into actual building practice for people to use it. I have a friend in academia who he's a folklorist, and he says, we generally say 17 to 20 years for academic ideas to somehow get commercialized. Generally speaking, most of the stuff in AEC, we've got kind of we don't know what the upper limit is because people haven't commercialized a huge amount of expertise that's just lying around out there for free that, like, universities have put out there. Anybody can read it, anybody can implement it. And so what we'd like to see in the future, bringing this back around to Zig's question, and we think is possible, is to take a lot more of the best practices, rely less and less on human intervention for basic stuff, so that you can start typing in things like, I need a hospital with 250 patient beds, and it needs an oncology clinic, and it needs an emergency room, and it needs etc. Here's the program, show me a hospital, right? And so these are the kind of things that we think are really possible, and far from it being a replacement for the professional, we actually think it distributes professional expertise where it's best applied. Because if you work on complex projects and you're a designer and you're considered mature in your early 40s, right, after 20 years or so in your career, if you've worked on big projects, how many have you worked on in that time? 5, 6? Now, those projects have thousands of problems that you've solved and you build up your expertise. But the moment, after you spent your career in healthcare, that somebody says, hey, can you do a skyscraper? You're at sea. Again, it's just a different building type, right? What a better world it might be for those people who need to bring expertise to a different kind of project if they could start with something they could rely on. Like, look, here's a basic skyscraper according to what the client told you they need. This is the stuff you should change. This is the stuff that you should not touch. Go, right? And so we've seen a little bit of that kind of phenomenon with Revit. Of course, I talked with lots and lots of people who've used Revit in the past, and I did get some information from some people in firms who said, the folks who are using a 3D environment, they get to intuition faster than we did when we were starting out, because they're able to put themselves inside buildings and look around before they exist. And this person recounted an anecdote where, somebody, a young architect, walked into a building and said that grid's in the wrong place, because she knew that she shouldn't be able to see the HVAC register from where she was standing because she had stood there in the model. And that kind of 3D intuition building up faster, not over 20 years. What if it built up over 10? What if it built up over 5? Like, how much better could all our professionals be if they could build up their building intuition so much quicker than was possible from the conventional, flat representations that a lot of us grew up with.
And to your point, I think for a lot of clients who they expect now to have the experience of what the building is going to be like, and when you show them pieces of paper, they're like, "Sorry, we don't read this. We can't understand that." It's exceptionally difficult for most people who haven't been trained in architecture and design.
It actually gets worse than we don't get this, because it's like they pretend they do. And so I just a few weeks ago, I talked to a healthcare planner who was like, I go into meetings and I talk to the nurses who run departments, and I show them, here's the plan and here are the interior elevations, and they go, and then I get to the point where I show them a 3D axon and they go, oh wait, is that really going to be there? Right. And suddenly, they start dealing with it not as an abstraction, but as a room they're going to have to be in and interact with every day. And, he's like, fifth, sixth meeting, suddenly they're like, oh, wait a minute. No, the glove dispenser can't be there because here's all the operational stuff that I didn't even think I needed to say to you, or has been such ingrained knowledge that nobody thinks to surface it. And we've run into this a lot in a lot of different contexts with engineers, with architects. They say, well, it should work like this and this and this. And you go back and show them like, okay, here's the thing that you said. And they're like, oh, wait, that won't work because of this thing I didn't tell you about. Like, okay. So, we have some customers that we iterate like this, and we just know this is how they work. They iterate all the time, right? They're like, oh yeah, here's 5 more things that we forgot to tell you. And then gradually the automation converges with the human expertise. And then it becomes, after that, human judgment in context, which is really the interesting part, right? Because software is not going to embody project values ever. You can enter in all the parameters you want, right? But eventually the owner is going to say, I don't want the counter there. I don't like it. You're never going to capture that kind of thing. So somehow, at least in an automated way. So you have to leave that room in these environments to say, well, we're just going to have to camp the building 5 degrees, because the geothermal well has to be here.
Yeah. And really, that's the true value of the design team, right?
Yeah,
is
absolutely.
solving that's where the real value, and I think the real challenge for the designers is not in doing some of this spatial planning sort of work, which as you said, saves countless hours. We have a question here from Andre Brookman, which is a little bit long, so bear with me, but I think it's very interesting. He says, hi, Anthony, I'm a computational designer with a civil engineering background. What is your opinion on generative AI? I think it's greatly overhyped with many everyday engineering projects that can benefit much more from rigorous and well-designed automation pipelines. Engineering design requires rigorous calculations and processes that need to be followed and are required, something that generative AI does not. With Hypar, do you use a combination of AI and, air quotes, traditional automation computational design methodologies? There's a lot to unpack there. Have at it.
I agree, pretty much entirely. Look, I think there are various computational techniques. There's a whole class of them that people throw into an AI bucket. However, I haven't met an engineer yet who would trust any tool that they couldn't open up and have a look on how it's working. I have direct experience with this when we were working on Insight 360, which is sustainability software that runs on top of Revit. We spent a couple of years just exposing the visual model to explain what this calculation was working off of, which we knew that engineers would open 2 or 3 times to look at, confirm that it was doing what they expected it to do, and never look at it again. Yes, you'll notice that when we have done some AI projects, it's very targeted for very particular instances. One, interpret natural language into reviewable procedures, right? Or generate, a facade from an image through recognition, which, is then interrogatable and editable, right? And so I think these new tools that are coming online have their place. I've seen some excellent work coming out of, for example, JLL has a nice tool that is just a natural language inquiry into databases they already have, because the previous procedure was, hey, IT department, I need a query that tells me this, and somebody writes a SQL query and yada, yada, yada. Now somebody can just write, who was responsible, for the caulking on the fourth floor, and they can get an answer. I think those kind of applications, those querying things, are really interesting. I think the interpretive of natural language applications, so you don't have to have everybody learn some new interface that they're not familiar with, is really interesting. But I'm not sure that anybody should be pumping, 60,000 buildings through machine language or, machine learning algorithm to find out how to build a building. I don't think it's a good idea. I don't think it'll work. But I've seen some interesting stuff. There's a company called Swap is generating construction documents using AI. I think they've gone a long way. It's not all the way there probably, but who knows what the future holds, but we're very particular about what techniques we apply to what problem, because we don't think any of these things are the hammer that actually puts in every nail.
Thanks. We have a question here from Sean Foster. What skill sets are needed if someone wants to extend Hypar resources or build their own Hypar pieces?
So we kind of prefer everybody write their stuff in C#. We made an early decision that was kind of the most performative thing that we could use on the web. However, we do have an infrastructure that takes in Grasshopper scripts. We have an infrastructure that takes in even Excel spreadsheets and can do some interesting things with them. But generally speaking, when we have customers who come to us who want to build up their own teams or expand their own teams, and they ask us, who should we be looking for? And we usually say, someone who can write any kind of code, but actually knows something about buildings would be good. Because I have sat down with organizations who, I say, hey, you guys should develop on Hypar. And they said, we'd love to develop on Hypar. We don't know anything about buildings. And unless we have those people who can talk to those clients to understand, when they say, the vertical stack needs to be here, and actually know what they're talking about, it's very hard for us as a sort of general purpose job shop to do something like that. So there's a Venn diagram here which has some overlap of people who can program on computers and people who actually know something about buildings, and there's a fairly thin slice in there. And so some of the things we're doing is to try to make that, back to the theme of democratization, of empowering people, is to provide more and more interfaces so people can configure this stuff without writing code. For now I would say C# development, knowledge of buildings, but more and more should become easier and easier just through the web service itself.
Great. Okay, last question. Would you say Hypar is applicable to AEC designs other than building layout planning? For example, water, wastewater treatment systems design with pumps, tanks, and filtering systems?
Yes, in fact, we have customers who are doing those kind of things, but also railroad corridors and that sort. These are fairly sophisticated customers with their own development teams that essentially are trying to accelerate their delivery by using our infrastructure, right? They don't have to figure out how to put stuff on the web. We take care of that for them, for example. But yes, no, it's entirely applicable. We do have sort of a nascent framework called Hypar MEP inside Elements that helps you do some of that, which is basically networks of equipment tied together by pipes, conduit, whatever you want to do. But early days for people who aren't doing bespoke stuff, but there's nothing in the platform to prevent you from representing just about anything you want.
Cool. I apologize to everybody who has questions. We had so many great questions today, and I'm sorry we didn't get to all of them, but I'm sure you can reach out to Anthony directly. Anthony, do you want to put your contact information up, or just tell us so we've got it online?
Yeah, and I really should have a slide that has this, so why don't we just make it live?
Okay, cool.
Drop me an email on LinkedIn. I'm Anthony Hauck. those two ways are pretty good for hunting me down. A lot of folks contact me on LinkedIn when they have a particular, thing they want to know.
Great. Anthony, thank you so much for spending the morning with us. What a delight. This was just so much fun. We're going to have you back again.
Oh,
Be really great. We'll see what the state of the world is and what the state of Hypar is, because everything's changing so quickly. For our audience, we've recorded this session. We'll place it on our website so you can share with your colleagues. Our website is centerforinnovation.org. It should be up in the coming days. Our webinars are also available as podcasts, although this is definitely a visual presentation. So encourage your friends to check it out. I'd like to thank the amazing April Willoughby for all the behind the scenes work she does for all CFI projects. And finally, if you aren't yet a member of the Center for Innovation community, it's free. Please add your email to our website and we'll send you information about really cool things. And we never give away your name or address to anybody else. So please join us. Thank you again to our sponsors who make all of this possible, and to you, our community of innovators, for all that you do to transform the industry. Stay safe and see you soon.
Thanks, everybody.